FastMCP 3 implements runtime component visibility control through an Allowlist mechanism that dynamically filters tool availability based on tag-based metadata. This system-level access control pattern enables selective exposure of functionality by applying Boolean visibility transforms to registered components, overriding default opt-out behavior with explicit opt-in semantics. We will examine how the enable method's only parameter inverts the default visibility model, creating a restrictive execution context where only tagged components remain accessible while all others are programmatically disabled. The upcoming code demonstrates this Allowlist configuration by tagging tools with safety metadata and applying a server-wide visibility constraint. From FastMCP, import FastMCP. MCP equals FastMCP server. At MCP, tool tags equals safe. Def read-only operation, SDR. Return read. At MCP, tool tags equals safe. Def list items, list SDR. Return a B, C. At MCP, tool tags equals dangerous. Def delete all SDR. Return deleted. At MCP, tool. Def untagged tool SDR. Return untagged. Hash only enables safe tools. Everything else is disabled. MCP, enable tags equals safe, only equals true. Hash client C, read-only operation list items. Hash disabled, delete all untagged tool. This code demonstrates FastMCP 3's Allowlist-based component visibility control using the only parameter. The pattern creates a restrictive environment where only explicitly enabled components are accessible, rather than the default blocklist approach where everything is enabled unless disabled. This is particularly useful for security-sensitive applications where you want to minimize attack surface by default. The implementation uses tags to group related tools, with read-only operation and list items tagged as safe, while delete all is marked as dangerous. The untagged tool has no tags, demonstrating how untagged components behave in Allowlist mode. When MCP, enable tags equals safe, only equals true is called, it switches the server to Allowlist mode where only components with the safe tag remain accessible. This overrides the default behavior where all components would be visible, unless explicitly disabled. The trade-off here is between security and convenience. Allowlist mode provides stronger security guarantees by default, but requires explicit opt-in for each component or group. This approach is ideal for production environments where security is paramount, but may require more maintenance as new components need to be explicitly enabled. The code also shows how untagged components are treated. They're disabled in Allowlist mode unless specifically enabled by key or name. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core server functionality for the Model Context Protocol MCP framework. This class serves as the main entry point for creating MCP-compliant servers that can expose tools, resources, and other components to clients. MCP equals FastMCP server. Creates a FastMCP server instance with the identifier server that will be visible in MCP protocol handshakes for client identification purposes. The string parameter serves solely as a label and doesn't configure any operational behavior or mode. At MCP, tool tags equals safe. Def read-only operation, SDR. Defines a FastMCP tool function named read-only operation that returns a string and is tagged with safe for access control purposes. The decorator automatically registers this function as a callable tool in the MCP protocol, using the function name as the tool identifier and generating input validation based on the return type annotation.
Return read.
Returns the string literal read as the output value.
At MCP, tool tags equals safe. Def list items, list SDR.
Defines a FastMCP tool function named list items that returns a list of strings, with the safe tag applied for access control grouping. The decorator registers this function as a callable tool in the MCP protocol, automatically using the function name as the tool identifier and generating input-output schemas from the type annotation.
Return a B, C.
Returns a list containing 3 string elements, A, B, and C.
At MCP, tool tags equals dangerous. Def delete all SDR.
Defines a FastMCP tool named deleteAll that returns a string, with the dangerous tag applied for runtime filtering and access control. The decorator automatically registers the function as a callable tool in the MCP protocol, using the function name as the tool identifier and generating input validation from the type annotation.
Return deleted.
Returns the string deleted as the result of the function execution. This serves as a simple confirmation message indicating that a deletion operation was successful.
At MCP, tool. Def untagged tool SDR.
Defines a FastMCP tool function named untagged tool that returns a string value. The @MCP tool decorator registers this function as an MCP tool, automatically using the function name as the tool identifier and generating an input schema based on the function signature. Since no parameters are defined, this tool accepts no input and will return whatever string value the function implementation provides.
Return untagged.
Returns the string literal untagged as the result of the current function or method execution. This suggests the function is likely handling some classification or categorization logic, where the absence of tags or inability to determine tags results in this default return value.
Hash only enables safe tools. Everything else is disabled. MCP, enable tags equals safe, only equals true.
Enables only components tagged with safe, while disabling all other components in the MCP server. The only equals true parameter ensures that components without the safe tag are explicitly disabled, making them unavailable for client queries or execution. This creates a restrictive access control where only tools, resources, or other components marked with the safe tag remain active. FastMCP3's Allowlist mechanism flips the default visibility model from opt-out to opt-in, creating a security-first approach where only explicitly tagged components remain accessible. By using MCP, enable tags equals safe, only equals true, the system restricts visibility to only those tools marked with the safe tag, like read-only operation, and list items, while disabling everything else, including untagged tools and those with other tags like dangerous. This pattern minimizes attack surface by default, trading convenience for stronger security guarantees. The key insight is that tags act as dynamic access control groups, enabling runtime filtering without hard-coding restrictions, making it ideal for production environments where explicit opt-in is preferred over implicit exposure.
The decorator's pen writes safe tools in ink, while dangerous ones dissolve, leaving only whispers in the runtime's memory.